Hi, it's me Gabriel, and we're going to fly to Mars with the Interplanetary MFD. I know I told you it's not very fuel efficient, but it does the job. Now I've filled the XR5 Ravenstar with all the fuel I could put here on the slots. One of them is the LOX, and the rest is fuel. Again, not fuel efficient, not at all, just a way to show you how to get to Mars from Earth
rotation,
from Earth orbital to actually the surface of Mars and land on Olympus. Okay, so obviously we are orbiting Earth at around 358 kilometers, and what I want to do now is to go to Interplanetary and on menu, and here also on menu. Now we have already 62% of fuel, because that's what it took us to reach to orbit. Of course, because our ship was fully loaded with fuel, and it was very heavy, that ship, so you must take it into consideration. Now it's a very primitive way to go to Mars, what I'm going to show you. Again, it's not fuel efficient, but it will do the job. Okay, so first of all we go to orbital. No, we go to course, and then we'll set the target on. Target will be Mars. I just want to see if it's recording. Yeah, it does. So target, set target, I'll set target Mars. Right, so on the right side, open both MFD Interplanetary on both sides. The right side you share with the left one by pressing 0. If it was the opposite, you should press 1. So on the right side you go to, let's see the projection, not to higher orbit, press on plus, you'll get to course, and then it calculated automatically already our Hoffman transfer to Mars. And of course, please correct me if I'm wrong. Okay, so you go to page and then AB for outer burn, and warp the time until it will burn itself. It will do the ejection burn itself automatically. (4,140 delta V). Let it finish. Okay, now one thing I forgot to mention is the date. Look at that, Sunday, April the 10th, 2033. That's a very important date. It's one of those windows of opportunities we can go to Mars. I didn't study it with the TransX. I just Google on. You can Google on a cosmic train schedule, and you will see all the dates departing from Earth, departing from Mars, to Venus, to just check it out. Okay, so let me set here a reference to Mars, so we will know our distance. Right. Let's open those lights. So all in all, from takeoff until this stage, it took 1 hour 22 minutes. And now we can warp the time and wait 270 something days until we reach Mars. Okay, I'm accelerating the time by a factor of 100,000, which is the fastest here. If I'm not mistaken, yeah, it's 100,000. Have a nice voyage to you too. Okay, so go again to menu, and we can go to map. I'll put on display and center X and center ourselves, and the target will be Mars. So I don't want to mess too much with the scenario editor to warp the time ahead, because last time I did it, it didn't calculate exactly the time. So what you can see here, in this white dot, this is our ship. Here is Earth, and the yellow line, or the yellow circle, represents Mars. So we did that burn already, so we will encounter Mars somewhere around here. But again, it's not exactly, we will not touch the surface of Mars. We will be like 300,000 or 400,000 away still. So we have to wait now for that encounter. You can see here TN is time for node, but it's not always very accurate. So I'm going here on menu, set orbital, and our reference will be Mars. So we are catching Mars slowly. It's been 100 almost 150 days into the mission. Yeah, it's about half the time to get there. With this method again. So actually now we are crossing Mars orbit, but we will compensate it by the other side, because here we are going slower, and we will catch Mars eventually somewhere around here, that node here. So let's wait. Already 227 days into the mission. Let's continue. Now, as soon I'm not counting on time to node here on TN. It's not very accurate. What I do, I look here, and when this digit, the distance from Mars, will start increasing again, I'll place arrow burn to make a full orbit around Mars. So let's continue. Again, it's not fuel efficient. It's very clumsy way. I will say to get there, but it does the job, and the XR5 has enough fuel slots to actually make that journey. Okay, let me watch here. Actually, that's the distance between us and planet Mars. Let it drop. As you can see here, the delta V is dropping also, but it's still quite high. It's about the amount that we made from our first burn from Earth orbit. And then you will press AB for auto burn. Right, still dropping. Still got some more. This is our ship, that's Mars. Okay, now it started increasing, so I'm pressing auto burn, and it will orbit Mars. Not fuel efficient, no. Let it finish. Right, so it finished the burn around Mars. So now we are one of Mars' satellites, very distant satellites. Let's go here on orbit, and our reference, set it to Mars. You can change that projection and press DST for distance, and you will see our periapsis, and we will make some adjustments here. I don't want to smack into Mars surface, so I'll go very easy on that. See how the periapsis is dropping? You can see it right here. This is our periapsis. $4,000, $1,000. Now we are negative. That was I worried about. I don't want to get negative, but anyway, it will get. Reach the doors. Actually, you can leave them open. It's 500. Yeah. 300 will do. And here I'm going to menu and go on orbital. Reference Mars. Good. Let's continue with the descent. Now look at the periapsis. It will get negative eventually, I guess, because Mars gravitation. That's why I'm not a specialist, but this is my guess. Okay. Slowly. Just take it easy. Okay. Yeah, we're definitely on the negative side, but we will fix that in a moment. 8,000. Okay. Oh, just a bit more. I want to press outer burn now. Well, I forgot to. Actually, we can get rid of that extra of fuel tanks which are already empty.
LOX tanks full.
So still have 42 days of oxygen. So it's been 275 days into our mission. And let's press outer burn because I don't want that digit negative. Set it on 200 at least. No, 150, 200 it will do. Don't outer burn all the way. Now what? I can stop and do it manually. You can see our periapsis becomes positive. I'm looking right there. I told you it's not fuel efficient. It's not negative anymore. Let's wait until 200. Something like 200. $209 will do. Now I don't want to air brake in Mars atmosphere because it's very difficult and I really don't know. I've been practicing on that, but it's very difficult to do that. So let's continue. Let's see Mars.
Rotation.
As we are dropping into Mars of not atmosphere, but there we go. You can see it already.
Off.
Now what I want to do is go again to interplanetary orbit. No. Interplanetary and reference Mars orbital. Circleize. Now wait until we go until our altitude shows 209, and then I'll press auto burn to make a full burn around Mars. Guess we passed Phobos and Deimos, so shows us Mars. That's good. Just a second.
Rotation.
Our HUD is yellow. Yeah, and Mars is also has the same color, orange. This is very important to see that. Now it's better.
Off.
Okay, let's continue with the descent. Make sure our periapsis doesn't change. And wait for 209. Reference Mars, that's fine. There we go. I'll press auto burn just now and let it just orbit Mars. Well, that's good. 211 by 211, altitude 211. Right, so I guess we finished with the interplanetary, as we are orbiting low Mars orbit. It's not very low, but still. Let's go on surface mode, and here let's go on map, and let's set target to spaceport Olympus. As you can see, we don't have any standard pressure nor dynamic pressure. And let's go here on base sync and put our target to Olympus, and we see that in 5 orbits from now we will be offset by 355 kilometers. So let's go ahead and warp the time for 3, 2, 1. You know what? I'll continue, and I'll search for another a better solution from that. That was our last orbit. So in 8 orbits from now, again. So now it's 200 in 4. I guess I'll go with the 226. This is the last orbit. Yeah, because we are already 276 days from into the mission. We have 40 days of oxygen still. Anyway, let's minimize that to number 1, and let's change the offset distance. I'll go on track mode. I'm not sure if it's normal plus or normal minus, but I do want to correct. Okay, and let's go here and set the hot data MFD to apiapsis, periapsis, g-force, and kilometers per hour, like that. Okay, so let's go back here to base sync. Okay.
Scram doors are closed.
Scram. It's just a small burn of adjustment, and it also influences our apiapsis.
Scram doors are closed.
Do that till 0, something like that. It will change eventually. 90 kilometers, 81, 70. Because remember, in the next orbit we are going to land on Olympus. I told you it's not fuel efficient, but I hope I will make it. Yeah, 5k, 1k.
Scram doors are
Oh my god, why I'm pressing the Alt? Okay, 32, 1. Ooh. I guess that's close enough. Small adjustment. That's close enough. 72. No, again. 23. That's fine. Let's go on with 23 on prograde, and go ahead and open up the APU and the hover doors. So we have the retro doors open, and I want to open the hover doors because eventually we will need that. I guess we can close the autopilot now and go here. I know it sounds crazy, but it does the job. It makes the job. On baseland autopilot and click base Olympus. Okay, so we have retro scram. I opened the scram. Oh my god. Sorry. Close. Hover. And I'll put the air brake just to slow us down a bit, and make sure it's Olympus, and I want to confirm and execute. So it will start our deceleration and landing. It's not gonna land actually very. We will have to make a manual landing. Look at that, it's a sunrise over Mars. That's nice, isn't it? Sunrise over Mars. That's nice. That's a nice view. Okay, let's continue. FOV will be 40. Okay. Now let's let's set the nav in calm to... We see here that pad number 1 is free. Now I know pad number 1 is 129.70 megahertz. So let's do that. Okay, 129.70. So the navigation receiver is set, and all we have to do is wait. Until it will automatically start our descent burn. Probably we will land on the dark side. No, I mean in the night time, in the dark time, because I still see that the sun will rise. Maybe we'll. I don't know. Right. So in 1 minute, it will hand off to the autopilot. Ignition in 30 seconds, 20 seconds. Ignition in 6, 5, 4, 3, 2, 1. Ignition. Confirm. Right. Let's accelerate the time just a factor of, you know what, 3. Then I will change that. You see, it starts to get dark. So I guess we will land on the dark, in the dark. And it uses the retro DAWs and eventually the hover to land on pad number 1 in Olympus, at Olympus. So it's basically using the hover doors to the retro and then the hover to slow us down. And there is Olympus over there. Again, it's not fuel efficient, but it does the job. And if it does the job, then it's good. I mean, 9,900 kilometers per hour. Olympus is 900 kilometers away. Okay, let's put it on 2 because I don't want it to crash. We'll just wait on acceleration of 2. I'm not touching anything, that's the autopilot. Let's sit here, surface. So we still don't have any dynamics or standard pressure. I guess at 100 kilometers, because Mars atmosphere is very very thin and quite low in atmosphere. I mean, if it was Earth, by now, far away, we would have some standard pressure and dynamic pressure, but not on Mars. A case. Switch to that view. I see. 276 days. Still have 46% of fuel. I mean, main fuel. And the air brake does help a bit to slow us down. No worry, we can still have that radiator deployed, because I'm watching here on the external and the coolnet temp, and it's still very minus on minus.
Mach 6.
That's it. It will stay now on minus 108 Celsius.
Mach 5.
$70K in altitude. Now we can see the smoke from the retro doors, retro engines. I guess
Mach
before that
4.
it was quite a vacuum, so we didn't see that smoke. Now, I did mention
Mach
that
3.
radiator. It's not all about the hull temp, the outside temp. Excuse me. It's also about the dynamic and the standard pressure. But it doesn't seem to get even near to what's Earth dynamic and standard pressure will or is, even on that velocity.
Mach 2.
Okay, I'm going and normal. I mean, I'm not accelerating the time. Here we can see already those pads, which I believe, yeah, that's our Olympus. Let's see here if we have a signal. Yeah, we do have pad number 1. We have signal. But remember, we are still traveling at 800 kilometers per hour and decreasing.
Subsonic.
Subsonic on Earth, not on Mars. Subsonic is on 700 kilometers per hour now. Because it's Mars atmosphere. Let it finish. Good.
Mach 1.
No, it's not Mach 1. Let's wait until the hover door starts.
5,000.
Hover engine.
4,000.
Man, you see?
3,000. Subsonic. 2,000. You are cleared to land. $1,000.
That's about what it can get. That base land autopilot. So I'll go here on descend hold.
900 auto start. Center of gravity shift online. Gear down.
Okay, so we have gear down and
gear down and lock. Rotation.
we are still 800 meters above the surface. So let's continue with that from now on.
Translation.
I'm using the translation and descent hold.
800.
I'm looking at that cross,
700.
so I know what's my relative position.
$600.
Gear is down and ready for landing.
$500. $400.
Best pad number 1. have to be very, very, very patient and accurate, because we don't have enough fuel
300.
to orbit Mars again and land again. Definitely not. Put it on 2 meters per second. Vertical speed. And just with the translation, I'm correcting that cross all the time. As the vertical speed gets oh my god, I pressed wrong button. As the vertical speed gets low and lower, so the sensitivity will increase, actually. So need to be very, very gentle with that. Wow, it's so sensitive now. Hypersensitive.
One hundred. $75. 50. 40. 30. Information. APU fuel 70%. $20. 15. 10. 9. 8. 7. 6. 5. 4. 3. 2. 1. Wheels down. Wheel stop.
Right. Parking brake set. Air brake.
Off.
Okay. So we landed. Can close that hover and retro. And welcome to Mars. Welcome to Olympus. We made it in 276 days, 15 hours and 15 minutes. Very raw method. I don't recommend it. It's not very fuel efficient, but it does the job. Exterior temperature minus 78 Celsius. Good. So we landed on Mars, on Olympus.